Hi, I've been developing software for over 14 years now. I started all the way back with the .NET Compact framework on industrial PDAs with barcode scanning tools integrated in them. Up until now, where I do .NET Core, mostly, to create APIs for several applications with Angular frontends or Xamarin applications. I've been a consultant for a little bit over 7 years, and I recently joined UCB in Belgium, which is a pharmaceutical company, as an internal developer. I was the first internal developer in that company, which is also a little bit hard for me to do because I have to change the mindset of the company. My name is Wesley Cabus. You can email me at wesley@godsharp.be, and you can find me on Twitter using that handle where I tweet mostly about the beers that I'm drinking. So, of course, you didn't come here today to learn more about me. You wanted to know more about chaos testing or chaos engineering and how to do this inside of your applications and services. So let's see what the plan is for the next hour. I'm going to start with introducing chaos engineering, because how many of you know already what chaos engineering is? With a show of hands. Exactly. So let's raise the bar first and show you guys and girls what chaos engineering is. And then, after introducing some examples of the companies that are currently well known for chaos engineering, I'm going to bring it back down. I'm going to scale it down to the level of small to medium-sized companies. Of course, I'm not only going to be talking about the topic, I will also show an open source library called Row that I created, and show you with some demos how you can start adding chaos to your .NET code bases. So, we all know Netflix, right? And most of us in here, we even have a subscription for Netflix. But apart from their marketing strategy and catalog of movies and TV shows, what makes Netflix so popular? Well, I'm not going to lie here. I have absolutely no clue. But I do know that if I'm using their applications on my PC, on their website, on my phone, the applications almost always work. And if they don't, I can simply quit the application and start it back up again, and then it probably will work. That's the equivalent of, have you tried turning it off and on again for an application? But the reason why these applications and their services work so well is because they use the cloud, of course, to scale their services and their microservices, but also because they regularly apply chaos engineering to their services, even in production. And to do that, they schedule, for example, a fixed hour time slot, where one or more instances of, let's say, the login microservices is going to be impacted by their Chaos Monkey, as you can see on the screen. And Chaos Monkey is, among many other things, an extra piece of software that they deploy on the same machine as where their microservice is running on. And it will spike the CPU up to 80%, meaning that the login microservice doesn't get the chance to actually do its work, because the Chaos Monkey is hogging the resources. Another thing that they can do with Chaos Monkeys is affect the network interface. So the login microservice gets the CPU time, but the responses are not coming because it's blocked by something else. And you'll get a timeout to that service. And of course, because of their infrastructure, you will not notice this because they have multiple instances. They will, once the service is being impacted, there's a router that says, oh, this service is not behaving properly, let me redirect you to another one that works. And then you won't notice it, but they will say, okay, we did a good job. We have multiple services, we know it works. One of the things that they can do, for example, to mitigate the problem of a service being behaving a bit erratically, is use the circuit breaker pattern. If you look it up, it's a pattern that allows you to say, I'm going to try to call login, and if I don't get a response back in the next few minutes or if it's continuously slowing down, I'm going to do something else. Like I'm going to call that one instead, or I'm going to ping a service and say, let's reroute this request to another service. And over time, Netflix has added more of these monkeys in their chaos toolset. So there's one for adding lag. There's the other one for the CPU. There's even one that disables an entire system. Or the biggest one, which is it's a gorilla, that brings down an entire availability zone in Amazon cloud. So they're just bringing down one region entirely and see if it still works. It's pretty cool if you think about it, but it's crazy if I'm trying to do this. Another example is Audible from Amazon themselves. And Audible is a library of audiobooks. And they are also actively using chaos engineering to stress test their services, and they use Gremlin to do that. So Gremlin is also a tool where you can have agents deployed on the actual machines that run your services, and also spike CPU, add lag, etc. But Gremlin was, I think, one of the first tools out there that also allowed you to change your Java code. So you could inject some extra code in Java that makes your services, your own Java services, start throwing exceptions, which is really cool, because now you can not affect the actual server where you might run multiple things on, but you can just say, okay, my code on that server is going to mimic that it's running out of disk space, for example. Really cool stuff. Now, chaos engineering, in effect, it's more about performing experiments than running tests. Because when you create a test, you define an assumption, and your test will verify if that assumption is true or false. You know, you write a unit test where you say, if I enter this piece of data in that method, it goes through a path in my application, and at the end, I'm getting a result that's equal to 2, or it's false, or it's null. And that assumption is going to be evaluated every time, and that helps us tremendously in validating our business logic. But when you start experimenting on the same system, you start to think outside of the box. For example, what would the system do if it can't reach your database? What would happen if we deploy our applications in, let's say, in Azure, in West Europe, North America, China, and then suddenly one of the regions goes down? Or we are going to upgrade our system. We have multiple microservices, and we're doing it one region at a time. So is our system designed to work if we bring our region down ourselves and spin it back up again? So I know that scaling it down in this cloud computing era, it's not really the best way to do, but while reading about chaos engineering and seeing videos about Netflix and attending a talk even about the topic from someone at Audible, I kept thinking the same thing. This is great, this is awesome, but no way that my company is going to let me do this at that scale. And if I would try to propose adding chaos to production, well, let's just say that I'm glad my manager is not in this room. Well, he might be watching the live stream, or maybe later the recording on YouTube. Hi, Philip. No, I'm going to bring this down to our level, because at our company, we're still, unfortunately, we're still running multiple services on the same service on-premise. We're moving everything to the cloud, but we're not there yet. So if I'm going to add an extra agent that's going to spike the CPU, could you imagine the other teams freaking out because their service is also down? I don't think they will like me if I do this. So if I'm going to add chaos, I'm going to add it in the code base. So I can control where it runs, when it runs, and maybe even have a specific environment deployed, so it's not running everywhere. I could have a chaos environment if I want to. And this might be the first step into convincing managers, other colleagues, other teams to also start doing chaos engineering, and maybe even in production. Although in the pharmaceutical business, that will take a lot of convincing to do. But you might wonder, do I really need chaos engineering at all? Because I can say that you should chaos test your services, but why? Because I'm running stuff in the cloud, I have multiple regions, everything's available, that's fine. I have unit tests, I have insights, I have monitoring, I know everything's running okay. Let me tell you about two situations. The first situation I encountered during my first job. I was working on the PDAs with the barcode scanners, mostly to create track and trace solutions in large warehouses, as you can see over here on the screen. And we were discussing one of our solutions with a customer of ours, and we asked them, okay, do you want an always-on solution, an always-online solution, or do we need to implement an offline mode as well, just in case you don't have a connection? Because in these warehouses, and especially in the year 2005, Wi-Fi was not that stable. And, well, of course, the company said, no, let's go for the always-on method, because it's a lot cheaper for us to implement. Okay, let's do that. But we can also offer you a wireless survey, so we can go through your warehouse and see if there's dead spots where you don't have a connection, to fix that for you, because you wanted an always-on solution. Well, no, you don't have to do that. We have an IT department, and they assured us everything's fine. We have a good signal everywhere. Well, I think you can already guess what happened when you deployed the application. People start running around, and all of a sudden, beep, crash. You guys did a bad job. No, we just told you, do you have a good Wi-Fi connection? But unfortunately, luckily we had good logging in our application, so we knew that the signal was dropping, gone. So we could say, do you want still now the always-on solution, or you want to give us some more money to implement the offline mode as well? The second situation is a bit more recent. It's not a personal experience, but a colleague of mine at UCB shared this one with me. He had to go to Rwanda in Africa for a project, and he quickly experienced that the data center over there, if you can call it a data center, was offline. A data center was offline. Think about that. That's crazy. It had been offline actually for days. It was not an hour or something. It was not a simple. It wasn't a power outage, but it was normal there. The people over there are used to this. But for us, it's unthinkable. If I get a call, hey, Wesley, your data center is down for a week, and you're telling me this now? What? Are you crazy? So the application that we built over there, it could withstand, because we already knew that the connection was not that stable. We just didn't know how stable. So we said, okay, if your application is offline for a second or two, a minute, even an hour, we should be fine. We have a log of events, and then we can replay the events later when we're back online again. But we didn't keep in mind that it could be offline for an entire week, so we really had to rethink our system. Can it withstand being offline for a week? Because it's not only replaying events, it's also syncing data from different devices. And if we lose some data in the pharmaceutical business, that would be a big problem for us. Now, these two cases, they illustrate the same problem. Dealing with a device being offline, or having a very poor connection, causing garbled data or missing data. And we as developers, we can typically simulate this by setting an emulator or an actual device, if you're testing on an actual phone, to the airplane mode. But that's cheating, because airplane mode disables all signals, so your mobile, your Wi-Fi, Bluetooth, whatever. But it also triggers a system event. So your application gets a notification that says, your network is down, so please keep in mind that something has to change. And you can gracefully deal with that situation. You can say, oh, okay, so if that event occurs, I'm going to set up a queue and use my cache and not even try to connect. But it simulates the issue of being offline. It doesn't help you find the issue if you actually have a poor connection, because you have no connection at all, and you got a nice notification saying you won't have network connections. So having a poor connection is really hard to test in the average office, unless you're going to, I don't know, put some aluminum foil around your Wi-Fi access points, or if you ask a colleague over there to plug the cable in and out all the time. It's actually funny to do. This is just one example of a situation that might occur on a device or in a service that's beyond your control. But there are many other situations out there, ranging from environments running out of memory or disk space, and it's not so funny when your database doesn't have disk space anymore. Or maybe even entire data centers going offline because of a natural disaster. There was a data center in the States that went offline because there was a fire. And because it was a very specific data center, all services were impacted, believe it or not. But okay, a natural disaster that doesn't occur that much, luckily, but it still pays to be prepared for them, especially in some sectors like financial sectors, pharmaceutical sectors, chemistry in general. So that's why I think over 2 years ago, actually, long before I joined my current employer, there's an idea in my head. I'd seen the talks online from Amazon and Netflix about chaos engineering, and I wanted to introduce that idea at the customers where I was currently working for as a consultant. But of course, on a smaller scale. Not because the companies themselves were small, they're actually quite big, but most likely they would be a little bit hesitant if I was like, hey, dear customer, I want to start, deploying something extra on your servers, and it's gonna spike the CPU, it's gonna lag your network, it's gonna maybe even delete random data from the disk. Is that fine? I think they would say, oh no, what are you doing here? Get out. So again, I wanted to have a different approach. I wanted to be able to make it more manageable in our code base. So again, I could choose where it runs, when it runs, and how it runs. And that's when I started working on row, and people who know Scooby-Doo know where it comes from. So in its essence, it's like a mocking framework. So when you do a unit test, you mock a service and you say, when I call this method or this property setter or getter, do this instead. And this is exactly what I'm doing here. If you're going to call a method, I'm allowing you to say, instead of returning the data, first you're going to wait for, let's say, a minute, and then return the data. And so you can see if your phone still works, or if it's timeout, or something else happens. Oh, yeah. Speaking about adding some chaos. I found an edge case yesterday while I was explaining what I'm doing here. So I decided to go ahead and fix those bugs. Oh, okay. I was going to fix those bugs and build a new pre-release of the package, which I'm going to use now in my demos. So let's all take a little moment of silence to pray to the demo gods while I switch over to Visual Studio. So here we are. Let me quickly get my script for my demo over here. Voila. Microsoft has created an awesome sample UWP application called the Van Arsdale Inventory Sample. You can find it on GitHub if you want, and when I publish the demo code, you will also find it over there. And this application showcases you know, a typical line of business application with the model view, view model architecture, support for SQLite, also SQL Server, you can switch, which is something that you typically don't do, but they showcase it anyway. And it contains some of the nice new Fluent design features from Windows 10. And luckily for me, they also use the Microsoft dependency injection library that was created or introduced with ASP.NET Core, which makes my life as a chaos engineer to be a little bit more easy. Let's start by adding a NuGet package to this application. And I have to tick the pre-release box here because I'm still in an alpha version. And let's search for row, and you'll see I currently have 2 packages in there. The first one, that's the core package. It contains all of the things you need to start affecting your services. And then the second one is specifically created for if you use Microsoft's dependency injection extensions for ASP.NET Core, or in this case, the UWP application. It makes it even easier to use this. And the more easy it is to use, the more users you get, right? As you can see, I only have these 2. I'm planning to add more, like Autofac and all of the typically used dependency injection tools, so to make it even easier for everyone to use. But I'm focusing on this for now because I need to have the core stable before I can go further. So I'm going to go ahead and add this one to the project. As you can see, it's updated yesterday. This is going to be fun. And while that's installing, I can go ahead and try to navigate to the service locator class. This is where they set up all of their services. So you can see we have a lot of singleton services, we have some scoped, and some transient. Nothing really out of the ordinary here. And right before they create the root service provider, I'm going to start by adding some chaos to the service collection. Voila. Now this application uses Windows Hello. So the first time you log in, you have to use a username password combination, but in order for you to make it easier to log on, you can configure Windows Hello and use your fingerprint reader or iris scanner if you have a fancy laptop to log into the application again. I don't have a fingerprint reader on this one, but I can still use my PIN code to simulate this. But I want to simulate what would happen if I log into the application with Windows Hello and my fingerprint reader starts malfunctioning. Because I don't know what Windows Hello will do. Will it give me a nice error message? Will it not open the dialog? Or will it throw an exception? How can I simulate this? Well, I've created a tool for that. So I can go ahead I'm going to add some namespaces first. Row and the extensions for Microsoft dependency injection. And now I can say, in the previous method, you saw add singleton, add scoped, add transient. Now I can replace those services by saying affect singleton, or affect scoped, or affect transient. And I'm going to affect, in this case, the iLogin service, which is implemented by the login service to start making this misbehave. And what I'm going to do is I'm going to say, okay, when you're calling a method like sign in with Windows Hello Async, throw an exception. New exception with a message Windows Hello is currently unavailable. Well, now, if I leave it like this, it's gonna crash every time. And even for me as a Lord of Chaos in training, that's a little bit too much. So let's make sure that it doesn't happen every time, and I've added some methods that you can use. So in the world of row, throw is an effector. It's going to affect the method you're setting up. And now you can add some triggers as well. So you can say, I only want this to run after a certain time, after it has been called n times, at random. I included it, but I don't suggest you use it, because random really is random. And you want to have an experiment. An experiment means you know when it's going to happen. But if you want to try it, feel free. Before some time, between 2 times, every nth call planned at a specific date time until it's called n times, or when it's called n times. You also see XOR or not, an AND, to allow you to say, I'm going to plan this tomorrow at 2 p.m. and after it's called 3 times. So you can really combine stuff here. But for now, let's choose what I'm going to do after n calls, and let's say 2. This means that the first 2 times, sign in with Windows Hello Async will run just like it's normally supposed to run. The 3rd time, and the 4th time, and the 5th, and so on, however, it's going to crash. This is actually one of the things where I had a bug fix yesterday. So let's see what happens. Let's compile and run this, and then get started to log into the application. Come on. Dun, 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 dun. Dear machine, work faster. There we go. So this is the application, and you'll see a nice intro, and I can say login with Windows Hello. So let me enter my PIN, and I'm logged in. Great. I'm going to log out again. Try this again. And this time I enter a wrong PIN code. And okay, this still works. And this is behavior from Windows Hello. So I'm not back into my application and back to Windows Hello. This is just Windows Hello doing its thing, saying you entered the wrong PIN code, so please try again. Let's try again. Still works, 2nd time. But now, 3rd time. Uh-oh. We got a crash. It's supposed to happen, right? So if I now start the application again, let's see what happens. 1st time, so I'm safe, I can log in. And we have an activity log showing a red 1 here, which means we had an error with saying Windows Hello is currently unavailable. And where did this happen? Of course, yeah, in my library. But actually it was here in the login view model, which called an asynchronous method called sign in with Windows Hello Async, and there is when the crash happened, because I said it should crash. So we might assume that if Windows Hello has an unexpected error, it crashes your application now. Not fun. Can we fix this? Yes, we can. Let's go to that login view model, and let's see what it is doing. So there's a method, login with Windows Hello, and as you can see, we were just a little bit naive and thinking that Windows Hello would always work. It might, I don't know. So let's fix this. Let's wrap this in a good old try-catch statement and say if result enter application. That's good. Let's move that here as well, because this is actually saying if something bad happens in Windows Hello, you can, or if you cancel out of Windows Hello, this is what happens. It shows you canceled out, so please try and log in again. But I have to do something else here. I'm just gonna be lazy and copy paste this. I can now say Windows hello. Oh. Windows hello is unavailable. Please use your username and password for now. Voila. And let's try this again. So now I'm gonna log in 3 times again, quite quickly after each other, but to show that we now fixed our bug in the application. And that's the thing with chaos engineering. You're starting to experiment to find edge cases that you wouldn't normally find with unit tests or integration tests. So in this case, I log in, fine, works. I try to log in, I'm canceling, you canceled. And the 3rd time, Windows hello is unavailable. Please use your username and password instead. So I fixed that bug. And if I try this again, because now it's 4 or 5 and so on, it's still gonna fail. But I can still do this and enter the application, which is good. A good user experience. So that's the first thing that we can do. The second one, let's start slowing things down. If I enter the application, you see customers, orders, etc. You have a list of customers you can get and a list of orders, etc. Let's say that our customers are coming from a CRM system and we have put an API in front because we wanted an extra API, but the CRM is being used like by multiple applications, so it's getting hammered with requests. We only have one server, which is a Pentium of 2000 years ago, and it's really slow. And we can simulate this behavior and see what happens in our application. So let's go again into the add some chaos method and say affect singleton. It's coincidence that almost all of the services I'm affecting are singletons. It's not that I can only use this method, but in this case they are all singletons. And I'm going to use the customer service now. Service. And here we have a method called get customers async. Now this method, as you can see, has 2 overloads. The first one is expecting a data request, and the second one has some extra parameters to skip and take for paging. But I know that in this case it's only going to call the first method, so I'm going to use that overload. So I need to enter a data request in here, a parameter. Of course, I don't have that request, but there's a thing in most mocking frameworks that you can use to mimic these parameters. And in this case, I can say, I don't care, just use any data request. Of the type, what was it again? Customer. Voila. So whenever this method is being called, get customers async, I don't care which data request is being passed in, I just want to affect that method call. And in this case, I was saying we have a slow CRM system, so I'm going to slow this call down by, let's say, 30 seconds. And again, I'm not going to do this every time. I'm going to only do it every second time. Yeah, that's good. I'm happy with this. So let's build and run this again. And now if I'm going to navigate to the customers list, you're going to see that's going to start slowing down. I'm slowing it down by 30 seconds. And if this application was a typical Windows Forms application built by me 14 years ago, you would start to see the typical behavior of a crashing Windows application, meaning it goes white, and the title bar is going to change into not responding. But this is UWP, right? It shouldn't happen. Well, fingers crossed. This is the first time, navigating to orders. And this is the second time, and I can still move the application. It's not turning white, it's nice. I'm seeing the spinner, okay. But it's still, I don't know if you can see this, but you still have the fluent design. I can still press buttons, yeah. So it behaves quite okay, actually. This is good, apart from the fact that it's taking a while to load the customers. But eventually, the 30-second period will be over, and then we'll get our customers. So it's behaving quite okay. But you might want to have a circuit breaker in there to, if it's going to take a while, just use the cache. So you can fix that also. But I'm not going to do that here right now. The third thing we can do, however, is let's play around with the activity log here. Because you see, you have a lot of events in here. And let's say that these events are being written to disk. And now let's mimic the fact that our disk is running out of space. So let's head back into our lovely method and say affect, again, singleton, I know, it's getting boring. I log service. When calling write async. This one has a lot of methods, and again, it has two overloads. The first one is taking an exception and some information, and the second one is only using string parameters. But I know that the exception one is calling the other one, so I'm only going to override that one. And again, with any, what's the first one? I think the first one is a log type, and all of the others are strings, so log type with any string, and then let's be lazy again. I need 1, 2, 3 more. Bam. And we're going to mimic running out of disk space, and running out of disk space means throwing an I/O exception. So throw, and I don't want to give it a message or something. I can just say, no, not IObservable, I/O exception. System I/O, there we go, voila. So I don't need to create an exception, I can also use this way, if it has a public constructor. So for SQL exceptions, that's not going to work, because someone decided that you should not be able to create your own SQL exceptions for some bizarre reason. There are ways around that, of course. And again, let's add every third call in this case. And this will start, oh no, yeah, it's good, it's fine. I was going to say something else, but every in-calls works just as well. But typically, if you run out of disk space, you don't immediately get disk space again. Oh, chaos, nice. This is not me, by the way. It's completely random. But it adds to the drama. It's cool. If you hear an alarm, get out. So, activity log still works, but let's try to update one of these orders. Because I know that if I save an order, it will also log something. So let's say this one is not pending, but it's processing, and I have used my credit card. Save. Works. First time. Then it was being shipped, and it was shipped on this date using Speedy Express. Save. Uh-oh. Yeah, crash, of course. Something bad happened here. I could go into the log service, but the funny story is we're using the log service to write the exception, and that also failed. So you don't have exception information now, which is not so great. But if you want to try and fix this, let's see what happens if we call this log service method. So you have write async, and I was making this method fail. And it's being used only here. And it actually uses a create log async method, which does the writing to disk. And it's using a data source and do this. But the problem here, in this case, is this method, while it's public, it's not part of the contract of the iLogin service, or the iLog service, better. So I can't affect this method. So I can't make this one fail, which I actually should have done. So I should add this to the contract, but then I expose this behavior for everyone, which is bad. So in this case, I know I can fix this here, but it would have been better to have another design where I have a, because in this case I have a dependency on the disk in the service that's logging. So this is showing bad architecture, which is also cool that you can use chaos experiments to show bad architecture. But this was still, you know, easy stuff. Throwing exceptions, slowing stuff down. I added something new a few months ago that's allowing you to also change what's being returned. So for example, I'm gonna comment this out because I don't want to affect or run this experiment now. Oh yeah, let me also do this because it would be actually not funny to have to wait 30 seconds every time for customers to arrive. But what I can also do is when I load the information of a specific customer, if it's in the customer screen or when I open them to edit them, I can change what's going back to my screen, which is cool. So again, I'm going to affect the iCustomer service, implemented by customer service, service. And now, when I'm calling, in this case, the get customer async with any, you can see it's starting to become easy now. I can say, return. So I'm gonna put this. I'm gonna say return something else, return something async, because sometimes you have asynchronous methods, and I wanted to make it easy for you to not having to deal with tasks. I can just say return null, or return null async, because you need to have a task of null if you have a asynchronous method. And I'm gonna use this one because I have an asynchronous method. This kind of gives it away. And I can just simply say, there's 3 overloads here. The first one is taking a function with a task of t and then a task of t. The second one is just a value expression. You can say create a random value. And the simplest version is here's what I want you to return. So let's try this one first. Customer model. I'm gonna zoom out again. Whoop. And let's say first name equals chaos, last name equals monkey. And yeah, not every time. Let's say every 3rd time. Yeah, good. So now let's run the application again, and we're gonna go ahead to the customer list, if it's compiled and running, and then we'll see something weird beginning to happen. And now I'm wondering if I did press, okay. So let's log in again. I'm getting my customers, and I'm going to start navigating through the list with my arrow keys. So I'm taking the first one and then whoop, whoop. So you see now I have a chaos monkey with customer ID 0. Everything else is empty. And here it's fine. And then it happens again every third time. Now if I try and open this person, it worked, but it was like, I'm not sure if this is going to do something good. So in this case, I have an ID 0, and I'm actually surprised that this screen is working. So that was a cool design, or a cool feature. But if I try to save this, oh, I can still do stuff, okay. But you see, my first name, though, was supposed to be chaos, and this was supposed to be monkey. But what happened is, it tried to fetch customer 0, and he or she doesn't exist. So this didn't work, but luckily the view didn't crash. So at least there's that. But it would also be cool if I could actually transform the customer, because now I'm just returning a fixed customer every time. I want to have, for example, in this case, Alexandra Winston, and say, well, Alexandra is not called Alexandra anymore, or she has a different phone number, or the customer ID is changed, or something else. Weird stuff. I can also do that. I can say, instead of returning a fixed model, I can use one of these expressions to transform what's coming out of the service into something else. Unfortunately, because I'm doing asynchronous stuff, it's not that easy, because you can't have asynchronous lambda expressions with method bodies, which is a limitation in C#. But there's a way around that. It just looks a bit tricky, because I have to use a func with a task of customer model, returning a task of customer model. Let's call it transformer more than meets the eye. And then we can say async task var customer is await task, return customer, and voila. And now let's transform this. First, let's see if customer equals null, just return null. That's fine. But if not, then we'll say again, first name equals chaos, last name equals monkey, and let's remove that picture. So let's say picture source is null, clearing the picture. So now I'm going to have to use my transformer here, which means I need to take the result from getCustomerAsync and pass it on to my transformer, which is easy now, because I can just say I have a task, and I'm going to call transformer with T. The only problem is now, I don't know in this method what T is. It's a task of something, but I have to say what is something. And something is a customer model. Model. Voila. Cool. And let's see what happens now if I'm going through my list of customers. It should transform the first name and last name, but keep all of the other properties in place. So I have the same ID, and it's still going to work if I try and edit them. Here we go. Logging in, going to customers. Ah, cool, I have an activity log error. It was an IO exception. That was my disk out of space exception. Let's go to customers, however, and say 1, 2, 3, chaos monkey, but you see the picture is gone, and I can still see the email address adrian4@vanarsdal.com. Customer ID is still filled in, still have a phone number, that's all still good. So I can go ahead and edit this person. And now it still works, because now I still have the ID, I can call the method again, and I get the information that I'm supposed to see. But if I try this again, 1, 2. So 1, 2, and then double click. You now see Chaos Monkey in my edit screen, which is cool. So I can really start messing around with the data. The only thing that I can't do in this case is transform a customer into an order. That would be really strange because it's typed. What I can do is I can affect the API. If I go a level deeper and change the JSON that's being returned, I have all the power to really mess with your application now and see if your application can deal with these situations. And it might sound strange to do these kinds of experiments, but let's just say someone is trying to do a man-in-the-middle attack. This is exactly what I'm doing in your application. And then you can see if your application can deal with this, if it behaves correctly, if you try to parse a customer, but you receive something else instead. What will happen? Will it crash? Will it just say, this is not what I expected, so let's just return null instead, or do it something else? I don't know. This works good right now. So, as you can see, it's rather easy to add chaos to your applications. And the demo gods have heard our prayers, so that's good. And I've done this now in a UWP application. But if you go to my repository, and I'll show you the link in the next slide, well, I can also show it here, then you'll see that there's a sample application for ASP.NET Core Web APIs as well. So you can mimic what happens into your API and then have it returning bad data or slowing down, which is cool, because then your API is mimicking bad connections. And because I'm affecting code, I'm not deploying something on the server. So I can use this in Azure App Services as well. And with the newly announced function library for Azure Functions, I can start messing around with Azure Functions as well. And that's really cool. Because that's something, Azure Functions or serverless computing, they're really difficult to slow down or add lag to because they're supposed to run good. But with this you can. So, using row, it's only the first step in the chaos engineering process. Because you cannot mimic everything by doing it in code. If you really want to start doing chaos engineering, you should really think going to that extra step with using chaos toolkits and chaos monkeys and whatever is out there. But it's a first step, it's a good step to start and to show to your people, your managers, your peers, stakeholders, that you can do more to help and deliver good software solutions, stable software solutions. And it might even convince them that chaos engineering is really worth considering at all. If you want to dive into row, I suggest to head over to GitHub and you can see the code, you can suggest new features, you can raise bugs if you want to, you can even help out because it's GitHub. Pull requests are always welcome. There's still a lot of work to be done before I mark the official V1 release because I'm not really happy about the entire API yet. Also, I want to make sure that I'm not introducing bugs in your code. Or, yeah, maybe I do. Who knows? It's chaos, right? And that's it, actually, which is perfect because I have 5 minutes left. So it's time for a Q&A. Are there some questions in the audience?
Okay, any questions?
Thank you very much for the talk. Actually, I'd like to ask, what is the main difference between the library and any other mocking framework like mock and others? Thanks.
Well, yeah. A simple mocking framework, they allow you to bypass the actual service. So you can say, if I call this interface or if I call this service, do this instead. And I'm allowing you to do exactly the same, but I'm helping you also by giving the typical things you want to do, like slowing stuff down, throwing an exception instead, or changing the data that's being returned. But I also call your actual service. So I still keep the implementation, and I call into the implementation, which triggers your entire system, and then I go back. While a mocking framework does what you tell it to do. So you say, if I mock this method, do this, but not call into that unless you call base as well. Some of them allow you to do so. But in this case, that's supposed to happen anyway. I'm just really a man-in-the-middle attack in your code. That's the main difference.
Okay, thank you.
Thank you. When we are intercepting the calls, why should we care about how the dependency is registered? Why should it be singleton or transient or whatever? Why cannot we just specify the interface and that's it?
Yeah. Well, in this case, it's because how this tool is set up. Because Microsoft Dependency Injection is a really simple IOC container. It only has the affect singleton, add singleton, add scoped, and add transient methods. So it doesn't support, for example, decorating a service like Autofact does. So if I'm doing this in Autofact, I could just say, hey, I have this service. Whenever you're calling this, add this thing first. But this doesn't support that.
I have my own extension for Microsoft Injector to support decoration.
Cool.
Probably I should publish it.
Well, link me to that, and I'll add it in there as well.
Thank you.